All right. So with that, we want to go ahead and jump into that tool session that I was just telling you about with John. And I hope I didn't steal his thunder with his topics, but it's a great thing about the Etherpads. You can get a sneak peek and get prepared early. So John, I'm going to turn it over to you.
Thanks, Mark. No, that's good thunder stealing. It's all good. So we've laid out some ideas to help us drive the conversation, just give people ideas of how to jump in. Feel free to just jump in with what comes up. So yeah, what we're suggesting is we sort of have a look at observability tools, then look at tools that make changes, and then go through sort of kind of like discussion on looking at how you deal with scale problems when they crop up, given we've spoken about those other sets of problems. And then I wanted to try and go about ways that we can help each other, like share tooling and share that kind of workflow. Excellent, got the Etherpad up. And move on to that. So yeah, feel free to, as you said, put your name in the participants list. I think we're just free to unmute if you want to join the conversation as well for this one. So yeah, let's get going. So I should probably introduce myself first, skip that bit. So on IRC, I'm John the Tuber guy. If you've met me on IRC before, I'm over in Cambridge in the UK. I currently work with StackHPC, doing loads of stuff on HPC and OpenStack and scientific computing. I started work on OpenStack in December 2010, which doesn't seem that long time ago until you start counting. And that was starting with Citrix, and eventually was working at Rackspace Public Cloud for a little while. Became Nova core reviewer as a Nova project technical lead for a little while. But yeah, most recently thinking about scientific computing and things. But welcome everyone. Do feel free to catch in. So observability tools. I don't know if people want to go through some interesting things. I guess what we've had some questions to sort of think about in each of these sections. So in the topics, you can see, I was kind of thinking if you want to share interesting horror stories that make you think about the topic and ways that you've come over these things. Sort of thinking back to the Rackspace Public Cloud days. In the early days, it was, the scary thing was people were complaining and we hadn't discovered it first. And then you have to go in and dig. So the more ability to see into things, you can got a lot easier. I don't know if someone wants to take first go.
John, did you ever have the experience that in a postmortem you changed what you observed and it actually saved you from having the same mistake twice at Rackspace?
Yeah, I was going to say one of the things. So I mean, most of this in my head, I was thinking about software tools rather than process tools. But one of the good kind of things is that you try and get onto this virtuous cycle, where I think it was really important to me that we could change and update the observability as we decided that there were other things to look at. So if when you dig in, you're going, I want to really raise that metric higher next time. One random example, I do remember that we were looking into like how fast VMs could start, and we were actually tracking in OpenStack notifications how long it took to get from like one service to the next. It turned out with cells, you could actually see how happy the database was for how quickly it got from the top cell down to the child cell. So when I knew that when that metric went high for one particular subset of cells, you could see that there was a problem there. Like one interesting observation. So there's a lot about, yeah, sort of trying to raise the visibility of what you are collecting based on the problems you've seen.
I can get the ball rolling with some experiences from previous job when I was working at, I first came across this kind of monitoring at scale in a very different context, which was working in sort of high-end HPC with Cray. And, you guys don't know you're born in terms of the richness of tooling and monitoring that we have available in public clouds, because back in those days, I think that the really big systems, these sort of most powerful supercomputers in the world, their telemetry was a large sort of max scale Postgres database, which could consume, say, 400,000 metrics a second or so. And everything was focused around providing just enough insight into what's going on. And so they were very much focused on choosing the signals. And because if you add more telemetry at that scale, it had this huge effect. And I think that sometimes maybe the tools that we have and the richness and the flexibility of the infrastructure might be in contention with scaling, so that if the more we scale, maybe the simpler the tools have to get, simply because we are working at such an enormous level of sort of richness of metrics, this real sort of haystack of data that's coming in from a cloud infrastructure. Is that true to say?
Yeah, I think so. I think one of the things so if you compare trying to monitor something on bare metal without OpenStack there, like OpenStack gives you those labels for things that you wouldn't otherwise get over time. So you actually have, this machine has an identity in the system, be it a hypervisor or a bare metal node, that has a thing that you can track over time as an operator of that system. I guess I remember first coming into large-scale cloud and not actually. So previously, before going to Rackspace at Citrix, we were more looking at private clouds and where people had very specific needs and knew the applications running on the system. So I guess it was interesting in the larger scale public cloud where you didn't know your users in quite the same way. You knew some of them and got direct feedback from them, but you sort of got to see the different patterns that way. So maybe let's move to the third topic of kind of like interesting stories of finding and resuming bottlenecks in the system. So I think we've got some people giving some interesting commenting in there. So I guess we could try a section as well, which is we said we're going to sort of share scaling horror stories.
Someone's put a well, not in the bottleneck section, but line 67, RabbitMQ Flatlining. That sounds like an interesting horror story. Who was it that?
Yeah, James, do you want to go through that?
Yeah, I put that one in. So fortunately, this was not in a production-facing cloud, but was in some scale testing that I did a few years back with OpenStack. And RabbitMQ basically has a high water threshold for its memory consumption. And when it reaches that, it just stops accepting new connections until it drops below that threshold, and then it starts resuming new connections. So you've got this beautiful situation where you're scaling the number of instances on your cloud, and the port count's going up, and Neutron and Nova are all super happy. And you can see like tens of thousands of messages flying around as everything gets created and synchronized and all that good stuff's going on. And then it suddenly goes silent. You get this, if you're looking at the RabbitMQ management interface and the graphing that it provides, which is pretty good. It tells you a lot, especially when nothing's going on. You hit that threshold of memory consumption, and it just stops accepting new connections. And because of some of the RPC style semantics that we use RabbitMQ for in OpenStack, that means that things are waiting to get a response, and they're never going to get that. So you don't see anything happen till all those things start timing out again. So and nothing can happen at that point in time. So no mutation of the state of the cloud can occur. So kind of understanding how far you can push RabbitMQ in terms of message throughput and numbers of simultaneous connections to deal with RPC calls from the various parts of the system is quite a key metric. And there are a lot of things that drive that connectivity. And I think the biggest thing that I found was actually the number of ports and VMs you're running. The number of hypervisors is interesting, but in terms of the pure load of things that the cloud's trying to manage virtually drives a lot of that connectivity. And in some of the older OpenStack releases, there were some well-intentioned concurrency parts to what Nova Compute was doing that had no upper limits. So if they would basically try and do as much in parallel as possible, and that could cause flooding of connections as well. So depending on what was happening on your cloud at any given point in time, you could really hit that hard limit, and then suddenly nothing's happening in your cloud, and it goes very, very quiet until everything starts timing out and you start getting the reconnection. But it does cause a bit of a reconnect storm after that point in time. So
thanks for sharing that, James. That's really interesting, and definitely brings back memories. So maybe for a production story, to make it more interesting. Well, to make it interesting. So one of the things when I was working at Rackspace, I remember sharing at an operator session before, was around upgrades. And I don't want to re-go about upgrades, but I think it's interesting because it's about observability and Rabbit as well. It was, Rackspace is one of the early users of Cells v1, and I guess the way in which all these problems have been resolved is it actually fed back into the Cells v2 work to stop this happening again. But there used to be a synchronization piece from the top to the bottom. And this was a particular, we had some metrics that were looking at the length of the queues in Rabbit. And just as James said, we knew that if you got beyond this point, memory escapes me how many hundreds of thousands of messages it was, we knew that we'd be out of memory on Rabbit and everything would fall over and stop. So there was definitely a point where we would upgrade to the latest version. It would be doing a bit more work, and the queues would start growing faster than the consumers were able to consume. And depending on the pitch of that queue, we knew how long we had to fix the bug before things got really bad. But it's sort of, in terms of like how best to roll things out in production, I'd like to say this is kind of an example of where A/B testing in production kind of helped, because we had several regions across the globe. We'd always deploy to the smallest region first. So you'd kind of get to see if the message rates were particularly bad in the small region and get to be able to predict from the performance you saw in the small region how it would affect you by the time you got to the large region. So you could actually hot fix the smaller region, then move on to the large region. And this is all stuff that you actually, no matter how much you're simulating and staging, you couldn't quite get the same thing as you got in real production. That was always a thing we found. Don't know if anyone else has similar stories. Maybe has anyone got a database story to like be fair to Rabbit?
I would have a database story.
That sounds good. Go for it.
We have a Ceph object store cluster connected to our OpenStack and our Keystone. And we had an issue that we support S3, and we use the Keystone S3 to support this, or the S3 supporting Keystone to support this. The problem is we have UUID token, and every S3 request creates a token in the Keystone database to validate the request. So at some point, we had someone moving our archive, a big archive of small files into our object storage, and it generated thousands of requests per second. We prune our Keystone tokens after 8 hours from the database, but our database grew to 80 gigabytes during that time with millions of tokens and filled our whole disk, and our whole database crashed several times, and we had to prune it, recover, and try to fix it later, and our actual final solution was to ask the customer not to do that, and hope that we can cache the tokens somehow.
So this is the leading question. Have you recently moved to Frenette tokens?
We have not yet moved to Frenette tokens, but this is on our agenda at some point.
Yeah, I remember that coming up very regularly in, before we had Frenette as an option. It's a great warning thing. I guess another thing is that, and we spoke about, I think there's some lines in the Etherpad about what is large scale. I guess James, you picked up on this a little bit. Like there's the size of your individual region. There's how many regions you have. Are you an edge site with millions of regions? And there's the rate of requests going through the system. So one of the things that you can also get on the DB side is the need to prune. So particularly Nova is good/bad at this, depending on how your opinion is. When you delete an instance, there's still a record in the database, and then you have to go and prune it. So over time, your database gets larger and larger. And certainly, I think this was at Rackspace with some of the smaller cells. There's actually a fixed size memory inside that VM. And there is a tipping point when suddenly your table scans and indexes become more expensive because the memory cache, you sort of trigger a different behavior in some of the queries. So certain queries get very slow, which is very similar to what I think you were saying about the UID system. When you get large tables, the indexes get large, and eventually you have problems with the index. Certainly there seemed to be a tipping point there. So this is on line 149 on the Etherpad. There was a comment from Dave H about Nova and RBD. Would you like to share that?
So this is actually two stories in one, but it's the same story. So originally we had the Nova services deployed on the bare OS a long time ago now. And the default OSU limit for file handles was 1024. Then we scaled up the Ceph cluster underneath it, and anything that had a large number of volumes attached, and some of our users' workflows at that point relied on attaching and detaching a whole bunch of volumes, they suddenly couldn't talk to more than, I think, 9 volumes, because it needed that many TCP connections to different OSDs in Ceph. So yeah, we fixed that one. A couple of years later, we ran into the same thing in a different disguise. This was after we had the service containerized. It turned out the container had been built with a 1024 limit at that point as well. So yeah, same problem, 2 different incarnations.
Do you say, when you see issues, do you check that more often now?
We set it to some insanely large number, so if we ever hit it again, then we've scaled our stuff a really long way. I honestly don't know how we could have seen this in testing, because our test Ceph cluster is very small, well under the 1024 limit that we would ever have seen.
Ties in with an interesting comment further up about a keenness to use Zool for testing configurations before they're deployed. And that sounds, I mean, that sounds like exactly the right sort of thing to do to avoid painful outages. But how do you do it to qualify a deployment at scale, where scale factors can find edge conditions far more effectively than a sort of a reasonable sized test cluster?
If anyone's done that, please do share. Or has steps in that direction. That would be really cool. I mean, going on the file limits thing, just to add another data point, I do remember hitting very similar issues with Elasticsearch, where it's one of those things that you just go, oh, just set it up, simply. Eventually you find the production checklist that tells you all of the things you should have done. And it sort of suddenly it becomes more critical by accident when people start using it as a single source of truth, and then it becomes more disruptive. So I'm guessing, have people got strategies to find time to invest in observability to try and make progress? Have people found ways in which they can do that? Any good tips? I guess Stig brought up one earlier, which is the so if you use Retrospective, then you can use a Retrospective as a way in which you can drive through a change that makes you hurt less in the future.
I think that's the key, isn't it? Rather than just patching these things over and fixing the exact issue that you hit, thinking a little bit more deeply about it and the potential for similar issues in future in a retrospective or other conversation, and then actually making the time to go back and fix those things is really important.
So we had another entry from Felix about UTRL3 agents. Maybe you're just saying beware the file descriptors. I don't know if you wanted to say any more. So maybe if we go a bit further down the Etherpad, there's been a discussion about HA Proxy, which is another great thing to look at the health of the system, like the rate of request and stuff.
I think it's been the best thing we added this year to our telemetry, simply because it provides you with a really nice visibility by endpoint and by return code on how your cloud is performing in a way which can be graphed over time. It's very nice high-level view of what your users are seeing.
Has anyone got things they want to share about HA Proxy?
Does anyone have any tips on how to take the huge amount of data that you would get from telemetry like that about every request and distill it down into something more useful, that a single or small number of metrics that can really give you a feel for how your system is performing and how healthy it is?
I can share a quick thing from Rackspace. We had what seemed like a relatively simple SLA, which I think we've spoken about quite a bit at previous events, where the SLA was to do with the number of 500 errors. So basically, if the API was returning 500 internal server errors, then the API was considered to be dead in some sense. So we failed to deliver your request. So we were, at that time, we were measuring like what's the percentage rate, what's the number of 500s as a percentage over time. When it dipped over a certain amount, that sort of broke the SLA. So I don't know if people have developed other kind of summarizing metrics in that sense, or what they found that's actually helped drive, understanding what the users of their service have been doing. If that helps spark ideas.
I just added a link to a presentation one of my colleagues gave to the Largescale SIG on what we did with processing HA Proxy to get histograms out. Might be interesting if you're following that.
So someone's made a note about the Largescale SIG working on Oslo metrics, which I have seen a bit about over the last few months, but I'd be interested to hear more about that. Was it Thierry or someone else?
Yes, it was me. So we've been working with folks from Line to get them to publish as open source the framework they are using to instrument the calls to RabbitMQ at the Oslo messaging level. So rather than have RabbitMQ's view on what it's receiving, try to get the OpenStack side view of what we're we're calling into RabbitMQ and how well that works, because we think that it will help us quantify or identify early the bottlenecks into RabbitMQ, and then drive potential solutions in terms of sharding the types of calls in various RabbitMQ instances. And it is a good example of what the type of things we're trying to achieve at the large scale SIG, which is how do we push back the limits in terms of scaling once you reach a certain size in a single cluster. So what breaks first, and how can we push back that? And it seems to be RabbitMQ is one of the first things that fail when we start adding nodes. So how do we instrument that? How do we detect that early? And there is an initial version of the code which landed in Oslo Metrics library that I invite everyone to check, because it's the proof of concept that is being used at Line for that specific purpose. But to make it useful for everyone, we need more engagement from other operators of large clusters, so that we make the tool useful to them too.
Are there any examples of specific issues that have been found through this new instrumentation that couldn't have been found through the RabbitMQ metrics?
I think Masahito will be here in the next session, and will be able to comment on that better than I do, based on their usage of the tool. But if you watch the presentation that the Line team gave in Shanghai at the OpenStack Summit in Shanghai, there's a presentation from the Line team on the type of problems that they detected with their RabbitMQ installation, and how they mitigated most of those by using the tools input in terms of how many types of calls are made and which ones are failing, and where do you have contention, that type of information. I'm looking forward others to try that framework and tell us how it's useful to them. See if that's something we should generalize for more than just Oslo messaging, but potentially Oslo DB calls and other Oslo level instrumentation of the calls that we're emitting from the various OpenStack services.
So something that came up yesterday at the upgrade session, I guess, was general feedback on, I think it was Rabbit 3.7 versus 3.8? I think 3.8 is the newer one that added, so among other things, that added the Prometheus collector. And so we spoke about HA Proxy, the latest version, having a native Prometheus collector. The same thing happened on the Rabbit side. I don't know if anyone's got experience of using that version and if that helped with visibility into the system.
I think 3.8 is still fairly new, isn't it? I can't remember exactly when it came out, so it might not have that much deployment or production exposure yet. So, but
it's
that sounds like a really cool feature. So,
yeah, I was hoping the folks that were saying about it yesterday were on. It's true. It's not. I think Erlang dependencies mean it's a little hard to upgrade sometimes in OS packages.
Yeah, I think from an Ubuntu perspective, we only put it into Focal and didn't backport it to Bionic because of the Erlang dependency issues. So,
oh, yeah, okay. Well,
So I'd be quite interested to hear from anyone who has experience of trying to benchmark and profile things at scale without the the system available of the scale that you're aiming for. How do you get to the next level without actually having that system available? There are various different techniques you can use to do this. I've tried different things in the past. I'm currently having fun with Ansible doing that kind of thing. Obviously, there are some things you only really hit when you actually do the real thing that you're trying to do, but there are also often lots of different bottlenecks and avenues that you can explore without having that hardware available. And perhaps I can kick things off just talking about Ansible, which is the language I seem to spend most of my life in these days, which has its own unique challenges. It's quite an interesting tool in that it claims to scale to really quite huge numbers of hosts. But if you try to write it without thinking about it or without actually testing it at that scale, then it's pretty likely that it won't. There are various things that are bottlenecks, particularly on the Ansible controller side, i.e. the host where you run Ansible. Things like template generation, iterating through groups and things. These all happen on the local node, and you can throw more hardware at that, but you get to a point and you will hit a limit. So I've been doing things with Kobe and Collar Ansible recently in a reasonable size environment, and looking at the issues that we hit there first. And one in particular is gathering facts. So when you get to a certain scale and you run naively with just gathering facts at the beginning of every play, then that can really take up quite a lot of time. So the tool that you typically reach for at that point is something called smart gathering and fact caching. So Ansible can gather facts from a remote system and then cache them locally, and then next time it will just use that cache, and that works very well. But there are a few areas where you can get tripped up there. So the context in which you execute Ansible might change and actually can influence the facts that get gathered. So if you depend on facts that can change over time, then you're going to run into issues there. So another particularly bad one is dynamic including of roles and tasks. So when you're talking about tens of hosts, then including a role or task file is it's pretty minimal overhead. But by the time you get to hundreds, it's taking tens of seconds to just include that file. So switching to a static import where possible can shave quite a lot of time off. And then I guess the last obvious thing to consider is skipping. So again, at small scale, skipping a task is almost instant, but when you have a large number of hosts, there is an overhead in just executing a task, whether it actually runs or not. So trying to reduce the number of skip tasks that you run is a good avenue to explore. I'm sure others have experience with scaling Ansible as well. Be interested to hear about it.
So maybe as an aside, when I was looking at deployment tools in the past, one of the ways that we try to think about the problem was that there's usually at least some part of the work that you want to do within at least an at-risk window where people know something's going to happen. So you try really hard to reduce the time in the at-risk window by doing pre-work that, in theory, is less risky. And to reshare an example that I remember happening at Rackspace in particular, was when trying to push out the new version of the code. At that particular time, we were using, it wasn't using containers, but using tarballs of VMs. So before the risk window, the team tried to push out the tarballs of the VMs to all of the compute nodes. Now it turns out there was a firewall between where the tarball lived and the compute nodes, which is where all the control plane traffic for the cloud went through. And actually, in pulling that tarball through the firewall, you basically took out the bandwidth for all of the control plane traffic, so the computes can no longer talk to RabbitMQ and such like. So there's definitely risk in that split. I don't know if you all have other stories on how you think about these optimization problems for, you know, operational activities at large scale. Again, this is one of those things that when you try it in staging, it doesn't hurt you in quite the same way.
So if you have, Prakash here, if you have in Rackspace multiple zones, and if you are running some large applications across the zones, does the load balancer go through the internal network, or does it go through external? How does it happen, the balancing?
So I'm no longer at Rackspace, so I don't want to speak to them what they do today. This is just resharing what we did in the past. In that particular case, it was just that you wanted to track traffic going through to the hypervisors. And as a common pattern, you can put a firewall there. So it wasn't really a load balancer as such. It's just that there's when you firewall off part of your infrastructure, if you're not careful, that firewall can be a bottleneck. I've seen it in similar. It's the same if you're trying to actually, if you're using firewalls in any of that kind of way, right, you get the same problem. It's just that if you're not 100% sure of where the your topology, it can hurt you. That makes sense. As in, you're not sure where the bottleneck is until you hit it sometimes, if you don't have full visibility into everything.
That's right.
So I think the official end of the session is in 10 minutes. I don't know whether we'll stick to that. I think we probably started a little late, but just thinking in terms of covering the topics, we've got a few different ones to cover. John, what do you think?
Yeah, I was thinking of moving towards the ideas on sharing, if that makes sense. So I guess this has come up quite a bit already. Like Thierry gave a great example of someone finding something really interesting and sharing that with the community. I'm just wondering if there's ways we can think about, you know, what are particular efforts that people want to share more on. So offering up an example, or sort of two examples that have come up a few times at various, I think it was a security SIG open dev event previously, at one of the security SIGs at the PTG, I think. Wazar came up as an interesting sort of security and auditing system as a really interesting way of people, you know, an example of people sharing their list of things that you should check to monitor the security of your system. So in terms of like as a group effort, having that sort of group think and sharing that through a tool, Wazar seems a great example of that. I guess I'm a bit biased, but I kind of want to say sort of like the deployment tools in OpenStack are doing similar things in the sense that Collar Ansible, you know, out the box can give you sets of monitoring and sets of, you know, it gives you the ELK rules and FluentD rules to start collecting the logs centrally and start collecting that, and you get an awful lot of information. So certainly with, we certainly saw in one upgrade going from Rocky to Stein, there was a huge difference in improving the collection of that centralized logging. There's just one example. But I guess I'm wondering how people are thinking about this. Yeah.
I think generally monitoring has always been a bit hobbled because there's so much divergence or diversity in what people use, and it can make it quite difficult to find common infrastructure. But I think what you've just called out there is a couple of examples where it has worked and it's demonstrated the advantage of sharing these things. So it's pretty clear that it's something that actually would be a good idea to find ways to do more of, I think, for everyone's benefit.
I don't know if people have got the OS Ops repo had a certain amount of activity about, like, this is an interesting script for visibility or for, you know, doing X. I don't know if people have. It's not had, you know, I guess there's been less contributions recently on that. But that kind of thing, I guess there's one line in here that has a whole load of +1s, which is it feels bespoke to my needs, and I think I'm wondering how, like, if someone feels like their system is bespoke to their needs, I don't know if they want to share why they think that, to see if that is true. Just a lot of the time it feels like it's just scratching my itch, it's bespoke to my needs, and then when you share that in sessions like this, you suddenly just, you know, actually there's loads of people that would like to see that. Oh, that'd be great, Dave.
So I put it near the top of the Etherpad. We have what I described as a hacky script. It looks around the free capacity on the hypervisors, compares it to the various flavor sizes, and then records how many of each would fit in the available capacity right now. So then you can graph that later on with Grafana. You can look at it for trending. And that's useful to us for, well, it's very cheap and cheerful in terms of capacity planning. But also the users can see, you know, is OpenStack busy right now? Is it full of other people's stuff, or have I got a chance to stand up my monster cluster? Is that something that other people do? Is it something that other people might find useful? I have no idea, but it scratched an itch, as you say.
I'd say yes, because I think actually one of my first tasks that Stig asked me to do was to do something for bare metal in a similar kind of way. So I was looking at the bare metal host and seeing which ones are available, because we had exactly that question from the users of that cloud. Yeah, can I launch a big instance today? Is there space?
Yeah, that's exactly the sort of question we kept being asked.
Yeah, no, I think that's a great thing. So, yeah, I don't know what people think about in terms of visibility, in terms of helping, I guess. We should maybe all be more reactive at sending out those ideas.
In terms of that problem of how do I test these things at scale, which is a difficult one to answer. There is a contribution, I think, that we can talk about, which relates to a long-standing partner of ours at Verne Global in Iceland, and they've made available a system of 160 blades, 160 compute nodes, and we have a project with them which we are hoping to take shape over the summer to make that available to community projects to do testing at scale on physical real hardware. And the idea is that Verne Global are active supporters of open infrastructure and this community, and they want to be able to make use of this nearly new hardware. Well, it's a few years old. But for us, we're quite interested in creating a machine which exemplifies a lot of the different ways that infrastructure is used within a OpenStack cloud. So the idea is that we make it available for workloads, and we try and support the different ways that workloads would contend for a fixed space resource by using reservations and preemptible instances and things. But that's going to be coming online as a physical contribution rather than a contribution of code in the course of the summer. And I'm hoping we'll make it available possibly through a forum like the Largescale SIG or other things to enable scale testing of open infrastructure projects. Doesn't even have a name yet, so watch this space.
Thanks for sharing that, Stig. There's some good discussion on the Etherpad in pink, I think, saying on line 249. I don't know if someone wants to talk about that a bit more. So the OS ops about, there was a discussion on the mailing list. I don't know if someone could talk to
Yeah, that was
discussion.
this is Eric. Yeah, hi, this
thanks,
is Eric. Hi, how you doing? Hi, yeah, that was me. Yeah, we set that up back many years ago. I don't know, Tom Feifeld was still around, kind of thing. And there was a little working group that was kind of organizing it originally, and we changed the format of it a couple of times. But that group just kind of, was never really a formal thing. There's a wiki for it out there if you can find it. It still has Tom's name on it. He's the last one that edited the page. But we had a conversation on the mailing list. I think Mohammed started it up about trying to create some sort of organization to maintain that thing and make it a little more useful to people. But it just kind of fell off into the ether, and most people don't even know about it anymore. So I think some sort of organization around it would be good if, anyone's got a few minutes to volunteer, about like a once a month meeting or something like that, just to kind of come up with a plan for making it more useful to people. But in terms of the whole bespoke to me thing, it was kind of a place where you could put that sort of stuff. Even if you thought it was, just for you, you'd usually find out that it was actually something that other people needed too. Like I can think of one example where we had a conversation about Neutron not allowing discontiguous external networks back when it didn't offer that. And somebody had a little Python script that called ragged external networks that would go and create you a discontiguous IP allocation range and put it in through the API. And that person thought that wasn't, that was just something that they needed, and it came out in discussion at an ops meetup that, hey, I have this problem too. So even if you think it's just your problem, it's probably not just your problem. So definitely think about contributing to things there, even if even if it's something you think is just for you, stick it up there anyway, because it's not going to hurt anything. There's a generic repo in there that's not curated. It's just, if you think it might be useful, put it in there. It's not gated. There's nothing special you need to do.
Thank you for sharing that, Eric. That's a good idea. So looping back to Dave, do you think that would be a good way to share your script?
Yeah, I think that's a really good idea. We might need a tiny bit of polishing before we let it out the door, but yeah.
I like the idea that it doesn't have to meet sort of a peer review standard, because that would probably discourage a lot of people as well.
Eric might say more about this. They had a nice structure where you have a graduation process, so you can share it. So if when the second person wants to use it, they can tidy it up and maybe promote it. But it seems like a good way of getting discoverability.
Yeah,
I agree.
Yeah, I think so. And it was meant to be a low burden kind of thing, so that people didn't have to spend a lot of time. There's no particular code standards applied to it. Nobody's going to -1 you because you forgot a comma or something in your comments, or there's no particular reviewing going on. Although it would be nice to have a group that periodically went through there and made sure there wasn't drift that just didn't belong there. But it shouldn't take too much work. It's kind of taking care of itself. It is tied to the OpenStack operators IRC channel. So if somebody makes a commit, you'll see it pop up there. And every now and then you'll still see one go by.
Cool. So
John,
that's a pretty good time to stop. Yeah, I was going to say, Mark, I see your face appear.
No, this is amazing. I was really hesitant to jump in. This is a great thing to end on, though. I think there's some solid actions to follow up on. So great session. We're just going to take maybe like a 1-minute break so folks can have a little breather, and then we're going to jump into our next session.